So for the last few years, we've been hearing that the pace of change has been ridiculous and crazy for enterprises. I think 2020, you know, is just sort of hold my beer. I mean, it literally has made enterprises just have to turn on a dime, which does not come naturally. And one of the most hyped sources of innovation in the last decade is artificial intelligence. And in many cases, companies are talking about AI and how it may possibly be able to help them right now. And I will say that when I talk to when I give a version of this talk for business leaders, they find it very brass tacks and hands-on. I think right now I'm speaking to a much more technical environment, a much more technical audience. And so I think you guys will probably find it pretty floofy and high level. But hopefully we can steer in between and make it a dialogue when we get to the Q&A section in particular. So consider this a high-level overview of how AI is going to trickle and weave its way into the things that have traditionally been done by IT. And now we'll find out if I can advance my slides. All right, so a quick background on who I am and who I represent with my firm. I work for Zetta Venture Partners. We were founded in 2013. The Zetta is not for the Greek letter. It stands for a zettabyte, a trillion gigabytes. And so we were founded from the get-go to invest exclusively into AI and big data. And we only invest in startups that are doing AI, that are either building tools and frameworks for AI or that are looking to apply AI to solve problems like Opsani. And we only invest where there's B2B business models, nothing wrong with consumer, but you can't do everything. And so we focus on our knitting. And we invest at the seed stage, but we're a little bit institutional about it, which means we like to take board seats with our investments and write sizable checks. We're not just, you know, followers. I actually never worked for Microsoft. I applied there as when I was a college student and was rejected. I didn't get my internship, but I interned at Netscape instead, so that was pretty awesome. And but I spent 7 great years at VMware after working for a couple different startups, and then I had 4 good years at Facebook. So if you were at Facebook between 2010 and 2014, we may have overlapped. And so the firm exists because we think that AI is the next generational shift in computing. And that's looking like we're probably not wrong about that. So as my team thinks about kind of the history of technology and really of Sand Hill Road and Silicon Valley, it all got started. The proverbial silicon came from hardware, came from the semiconductor era and Intel. And the first great VC firms that you've heard of and love, like they got their start investing in systems companies. And, you know, then the 80s and 90s came along and software reigned supreme, and Microsoft was sort of the king in that era. And then, you know, lo and behold, my college internship, Netscape lands, and the internet arrives, and it changes everything. And all of a sudden, now we're able to not just get value from like writing documents on our sole computer and printing them out, but by hooking up the computers, you know, not only can we write and share documents more efficiently, we can actually do things that we never dreamed of in a standalone world. And the internet gave rise to the cloud, it gave rise to the SaaS, it gave rise to social, to mobile, things we think of as big platform waves in and of themselves. And yet, I think all of them I consider to be part of the big internet generation. And so it means a lot to me to say that I think that AI is the next big platform shift of our collective lifetimes. And as technologists. And I think that when that happens, not only do you enable companies to like create new features, new kinds of features that didn't exist before, you enable the creation of whole new categories, of whole new companies that, and solving problems that were impossible before. And I think that AI is going to let us do that because AI lets us go from workflow to automation. And it lets us not just automate things that humans were doing, it actually lets us try to crack problems that humans were incapable of solving on our own, like finding hopefully solutions to climate change or human health, which seem kind of, you know, more important now than ever. So thinking about how that impacts the enterprise, if you sort of break down a company into its component job functions, every one of these job functions does work that can be touched by AI and that will be sort of emphatically reshaped by AI. And this is like just a smattering of examples. Like I could go on and on and on about all the different aspects of every kind of work and every kind of job that AI will be able to touch. But if we think about the different pieces, like if you sit inside an AI organization, if you sit inside an enterprise organization, like, and work on building products, then what exactly is that going to look like? And so this is, I would call this an architecture. This is definitely not trying to be a technical diagram. But very loosely, if you think about what IT departments inside companies had to do before, you know, you had to buy some databases, usually from Oracle, but like by 5 years ago, maybe you already had it in the cloud. You were running SDKs and middleware on top of that. You probably bought some SaaS applications or some full stack applications that ran in your on-prem or through SaaS. And you probably had your own in-house software developers who are using traditional IDEs and other development tools like that to both build internal business applications and to generate business intelligence, to drive BI, to drive reports, etc. So all of that is still there. None of that's going away. But every piece of that is going to be touched by AI. So AI and new pieces will come in. So first and foremost, AI really centers data. There is no AI without data. And so building up your data layer becomes incredibly important, and most likely is going to happen in the cloud because frankly, it's what's made AI happen now. Like, interesting aside, what's made AI happen now is not a huge breakthrough in technology. There's some really cool stuff that's happened with deep learning in the last 5 to 10 years. But when AI really started to hit mainstream between 2005 and 2015, it was with ideas and algorithms that were 30 years old. I mean, they were from the 70s and 80s. And machine learning was regarded as like an impractical, foolish branch of AI that was viewed as not very promising because it required a really improbable amount of compute and storage. So it made those algorithms suddenly go from like, that's an interesting paper, but you know, you could never implement that in real life, is actually the cloud, is actually the cost of storage and compute coming down. So now this is possible, but we still need mammoth amounts of storage and compute, and that kind of implies cloud as your sort of core data layer, especially as you're starting up a brand new AI project. So you build your data services on top of that. You may in fact need third-party data services. In addition to software developers with their dev tools, you are also going to need data scientists using data science tools, and you're going to start generating that kind of business intelligence. Only instead of just describing or providing insights into what is true today, you're also going to be able to recommend, to predict, to prescribe. And you're going to build these internal business applications, not just with workflow, but they themselves are going to start having AI sort of as a part of them. And last but not least, those third-party vendors you turn to, selling you SaaS applications or on-prem applications, a whole bunch of those are going to look intelligent too, and are going to come from AI-powered vendors. So if you sort of put all those pieces together, what enterprise transformation requires, I think digital transformation is the big buzzword of the year, but it all comes down to basically building the capacity internally so that you can build homegrown AI-powered solutions, and also adopting intelligent applications externally and becoming a savvy buyer of AI. And, you know, most of all, you know, as is, the more things change, the more they stay the same. In AI, in IT, the devil is in sort of when do you build, when do you buy, and that's still true. So let's start with the build side of it, and what does building up this internal capacity look like? So here's sort of our chart, and we got to start with the foundation of data itself. So modern machine learning, for the most part, cannot get off the ground unless you have data that is clean, that is prepped, that is usable. And, you know, big companies, you know, compared to small startups, one thing they have in abundance is data. It's an embarrassment of riches. But getting it usable is the first challenge. And I have to say that to this day, when I talk to companies about what's keeping them from making faster progress with AI, it's the data and it's the talent. Like, those are the two things that everybody stubs their toe on. So it's not exotic problems, which is sort of good news, bad news. But one classic mistake that I see companies make is that, you know, they embark on this kind of field of dreams. If I build it, they will come, you know, data lake project, where if I just kind of assemble all my data in one place, then, you know, I'll wake up the next day and have cool AI systems running on top. And I think that a lot of people have run into trouble doing that. And I don't really recommend it. I recommend, actually, the enterprise is just what I recommend to startups, which is you have to start with an inspiration that comes from solving a particular problem, and pick one problem and solve it end to end. And yes, eventually you can become ginormous. Eventually you can boil the ocean and solve every problem that exists. But pick one problem, solve it end to end, that is going to be your inspiration, that is a clear internal customer if you're a big company. And that will pave the way for future expansion, and that'll let you get some points on the board. And so, like, the storage vendor, like, it's the usual suspects. There are a lot of good choices. you know, I think there's good reasons to pick any of these vendors. And so it's really, the hard part here is just sort of committing to a problem and then identifying and collecting the data that you need to solve it. And so building data assets, I mean, obviously companies have a lot of data inside, and that is just sort of stockpiled, but and again, one of the obvious ones is just sort of business applications. You have an ERP, you have a CRM, you've got a lot of valuable data locked up there. Your financial data, your customer data, those are probably like, you know, crown jewels and a really good starting point. But you may have IoT information. If you're a manufacturer, you might have sensors running through your manufacturing floor, your factory floor. That data potentially can be incredibly valuable. Maybe you have a mobile app, maybe you're a bank and you have a consumer mobile app that people use, and there may be like a really interesting source of data there that is good for marketing purposes, but for other kinds of purposes too. And there may be public data sources that are proprietary data sources that you can purchase or give to get in data sharing relationships. And it may be that the whole can be the greater than the sum of the parts when you accumulate all this data. So you know, lots of different ways to get data. Be creative. This is why it helps to start with a problem in mind, because then you can identify data based on whether it helps you solve that problem, and not just try to inventory all data that exists. And then, you know, and then really invest in the talent and the tools to prep and clean that data, and to build a system on top of it. And so the first systems you're going to build on top of that are either going to be, is probably something in the business optimization. You're not going to, you know, you're not going to start off on day one, you know, building a loan approval process on top of machine learning. You're probably going to start by something that gives you insight into what types of loans you're already approving. And so that might look something like a classic, you know, BI infrastructure, except instead of, and in fact, you can do BI. You can point Tableau and Looker at your big data and start to generate those kinds of dashboards and reports that you're used to. But you can also turn data scientists loose using Hadoop or other similar systems to get real visualization and insight, to drive predictions and forecasting. And then once you've done those things, and once you have that infrastructure, and once you're getting value from it and from the data sources, the next obvious step is, yes, to build that product functionality. So to start building homegrown applications powered by AI that drive your company forward. And that could look like a lot of different things. It really depends on the line of business. It could be a recommendation engine if you're Home Depot and you want to power a shopping experience for your customers. It could be an ad optimization platform if you are sitting on a media enterprise. It could be fraud detection if you're a bank or a payments processor. So a lot of possibilities, and it's, you know, it goes back to that inspiring problem. But you can sort of get there step by step. I guess that's the prescription. And so we sort of, you know, started with the data and then what you're going to do with the data. And so let's talk about also the people you're going to need. And so sort of jumping back to that picture of the different pieces and how they fit together. So collecting the data, transforming it, cleaning it, putting it into the data warehouse. These people are bearing the title data engineers. Maybe there's some data engineers in the audience here today. The good news is data engineers are just software engineers doing a particular type of work. If you have well-rounded full stack software engineers, they can learn the techniques and technologies of working with data pipelines and data prep. Likewise, your same old, you know, data analysts who were doing BI before, if they, you know, if they know SQL, if they know these tools, Tableau and Looker, then they can keep doing BI as well. So the new roles you're really going to need are data science and machine learning engineers. And these terms can often be used interchangeably, but I would say the difference is that a data scientist may be writing code in order to generate a report or get an answer, but you're rarely going to find a data scientist who, and a data scientist may have all kinds of backgrounds. I think almost anybody who's gotten an advanced degree in the sciences, the social sciences, or the natural sciences, or engineering disciplines in the last 10 years have picked up at least some really good statistical analysis techniques. But whatever background they come from, whatever tools they're using, they're probably, like, their output is a report. And they're writing some code for the sake of generating a result. Whereas a machine learning engineer is typically going to be someone with that computer science background, maybe math, and they are someone whose output is a program, is code that is a model and code that can be deployed and run in production and sort of be repeated and automate its outputs. So you're going to need some from column A and some from column B, depending what your internal projects are. And you're going to want to equip those people with tools, with the right tools, which many exist. I will name check one because Domino Data Lab are friends of the family. But they have really become one of the sort of gold standard model management and model operation systems for big enterprises. And so they provide sort of the complete environment for managing models, for collaborating across models, for deploying them to production, you name it. But you don't have to pick Domino. You can pick SageMaker. You can pick any number of other tools or stitch together different best of breed and open source tools. The important thing is that there's going to be a new set of tools and platforms and stacks to support in addition to what we're used to with traditional software development. Okay, so that was the homegrown internal capacity. Part two is of build versus buy is buy. So in many cases, it may just feel more tractable and easier to get going with adopting technology where somebody else is doing all that hard work of building up the AI-powered stack and of assembling that team and of assembling those tools. And you can get a ton of value from AI without doing the heavy lifting of building your internal capacity. Because a lot of the things you want to do with AI, whether it's coming up with better marketing programs or or better quality assessment, is not necessarily something that's a competitive advantage to you. And so those are things that that you should turn to the tech ecosystem and to vendors to provide. So those fit into the sort of enterprise IT stack, just as you would expect. One difference between AI-powered applications, unlike sort of traditional SaaS, is that they may sit on top of your system of record. It may be that instead of just sort of buying it and firing it up and logging in, what you actually need to do is power these systems with the data from your own ERP or your own CRM. And by examining and operating on your data set is how it's going to make personalized prescriptions and recommendations to you. So that's the architectural difference. And then, one reason why we think that AI-powered software teams products have the power to be disproportionately valuable to enterprise customers is because if they sit on top of your ERP, but also the ERP of every other customer, then you start to get something like a data network effect, where as that customer data feeds into the system, as the system provides you with a recommendation or an intelligently powered feature, as your users and employees interact with that system, the model is trained and gets smarter and smarter and smarter based on the interaction of your users and your data with the model. But at the same time, that model is getting smarter and smarter from every other customer that's using it too. I think maybe the analogy that's probably top of mind for most people in terms of AI and its power to learn is that, the thing about self-driving cars is that when you're driving one, sure, the model may make some mistakes, but it's going to learn from mistakes that are made in your car. But you, the human driver, only learn from your own mistakes, hopefully non-catastrophic ones, whereas the AI is learning from every driver who's gotten an autonomous assist. And so it can learn orders of magnitude faster than any one human driver. Same thing going on here. If an intelligent CRM or an intelligent, demand planning system is learning not just from what is going on with you and your customers and your usage, it's learning from what's going on with every single customer ever. And so it's improving in the way that interest compounds, the value it can create for you compounds, and it can become more and more accurate over time. So that's one reason why we think that AI-powered solutions, if pointed at the right problem, have a lot to offer. Now, something I spend a lot of time thinking about when I'm thinking about whether to invest in startups, and that you should think about if you're thinking about buying from AI-powered startups, is, is AI necessary or sufficient to solve this problem? Is this problem too hard for AI, and does it really require a human being? In that case, AI won't be helpful, and there's no compounding value to be had. On the flip side, some problems are simple enough that you could solve them with a program and a couple of rules, or a linear regression model, which is not really AI. In that case, there's also no compounding value to be had because the problem is 100% solved the first time. And so you're not going to get that kind of incremental benefit from additional customers. So somewhere in between are the really good machine learning problems where a vendor is just going to be able to sort of disproportionately do better for you than any non-AI powered solution, and then any internal only powered solution, because you're participating in the network effects of the entire customer base, not just yourself and your own data set. So I believe this is going to impact every line of business, but I thought it would be good to give some examples. And of course, one of them is going to be our wonderful host and sponsor tonight, Opsani. So if we think about the different, the different leaders or the different job functions inside a company, probably one near and dear to everybody here is the CIO and the data center itself. And I think that, I don't know, I think IBM probably coined the phrase autonomous data center like way back in the 60s or something, but I certainly remember sitting at VMware in like 2005 being like, yes, virtualization, we can finally make the autonomous data center a reality. And I think for sure virtualization was a key ingredient without which it could not have happened. But I think it is only now, as machine learning is approaching maturity, that we truly can kind of live up to some of that vision and hope, that holy grail of a data center that can be kind of self-healing. And so Opsani sits in one part of that, and the part of that is performance tuning of services. And I may not be exactly on marketing message for Opsani here, sorry, but this is just colored by my own life experiences working both at VMware and at Facebook to really try to make high performance software. And there were always a small number of human beings who were really expert at the art of performance tuning, but most people couldn't. And you try to get their help to come help you fix your part of the stack and make it faster and better. But it was extremely difficult. And it was difficult because the kinds of expertise you have to do good performance tuning is sort of bigger than any one human head. Because there is no one right configuration. There is no one right instance type and instance size that is correct to trivialize this, that is correct for every single workload. There is no one right Java garbage collector. There is no one right thread pool size. There is, there are a million, that's an exaggeration, but there are probably thousands of configuration settings that really matter and affect your performance, each of which have maybe dozens or more of possible settings. And when you consider the combinations, like this gets combinatorial really fast, and we're talking about, silly made up sounding numbers of possibilities. Moreover, to know which one suits the workload, you both have to really intimately understand all the code of the application, which maybe if it's a small enough application, a few developers have in their heads. But you also need to be intimately familiar with how the infrastructure works and how it all interacts with each other, which maybe a few DevOps people have in their heads. And there's probably no human being that has both kinds of expertise in their head. And so this is just like a problem that humans are bad at. And so it's actually a really, really good problem for AI. The founders of Opsani used deep reinforcement learning to actually continuously monitor traffic and application workloads and use it to identify the best possible configuration setting. And so if you believe in CI/CD, if you believe that you should be continuously testing and continuously deploying your code base, then at the same time, you have to also be continuously optimizing it. And what's great about Opsani, and I won't make this too much of a sales pitch for them, is that they can find profound savings as a result of this. When I was at Facebook, we would send half a dozen engineers for 6 months to grind out 2%, 3% improvements in application startup time, because it had such a big impact on the happiness of people using Facebook if the app didn't take forever to load. Opsani can find like 20% performance boosts. And even more importantly, where Opsani really shines is in its ability to optimize infrastructure so that you are not overpaying. And they're able to find like 50% cost savings, like where you're overspending, you've over-provisioned your infrastructure by 2x because you're using it wastefully and not properly identifying the bottlenecks. Like that's crazy town. I would not have ever guessed that sort of prominent high-class software organizations had written applications that were deployed to the cloud that were literally configured to use twice as much compute and other resources as they needed. And it's not that they're sort of sitting there at low utilization, it's like, we'll turn it down. It's that the bottlenecks move around when you reconfigure the infrastructure, and you find that you had over-provisioned to fix a bottleneck that you didn't need to. So anyway, the savings to begin are magical, and you probably can't solve this problem without AI. This is not like just an automate the human away low-cost solution. This is a like solve a problem humans can't solve. So I love it for that reason. But we work with lots of other companies, and so to give a different example, one that falls more in the ops category, is go back to that example of a company that is a manufacturer and that is thinking about a production line, and that maybe has a factory or a manufacturing floor that is heavily instrumented with IoT. And so what it turns out we can do with that, because IoT data is time series data, which machine learning is super good at crunching and figuring out, can we identify better than your monitoring tools if you're going to suffer an outage? And it turns out, why, yes, we can. When we put together all the different signals and all the different features across the process, across temperature, across jitter, across productivity, across the age of the equipment, across the way the material that's passing through the equipment varies, it turns out that we can identify, in fact, when an outage is going to happen or a failure could happen before it happens. And so you get kind of, you know, if in the data center, the autonomous data center has been our holy grail, like predictive maintenance has been the holy grail in manufacturing. So being able to figure out that you need to do maintenance before it becomes dire, you can increase yield, you can reduce downtime, and that goes straight to the bottom line of businesses that, you know, are big employers of people, and you know, probably if they stay healthy, then our economy stays healthy, and we keep toilet paper on the shelves. So that's probably also a good industry to help out. So pulling it all together, and let's wrap this up and get to Q&A. Like, we can build internal capacity that requires new kinds of services. It requires a big investment in your data. It requires a big investment in talent. But what you get out of it is pretty incredible. And working with vendors who can solve these problems, you can get a new kind of value that is significant and beyond what we could get in the past. I think, you know, a much more significant gain than just going from adopting on-prem applications to adopting SaaS applications, which was already a really big gain in how we bought software. And so, you know, if you were sitting there in the technology department of a company and people are coming to you and saying, so is AI really going to be able to help us? Like, you know, what do we do here? I think hopefully this gives you at least some starting points to think about how you might approach it, you know, which is defining your data strategy, starting with that inspirational problem, accumulating the data, and you know, in the end, it comes down to talent and investing in your people and equipping them with the right tools. And if you do all that, like, it is a big change. It is a big shift in how we operate and build technology. But I think the net result and what's powerful about it is that it keeps getting better as it goes. And so the value from it never stops. And so that's probably enough of me monologuing. And maybe I will actually stop showing my slides so we can all see each other's faces. And maybe we can just chat. And happy to answer questions or you know, kind of riff on any of these ideas. Or I know for sure you've got several folks from the Opsani team here. I know for sure they'd be happy to talk about their platform and how it works too.
Okay, thanks so much, Jocelyn. That really was an awesome presentation. Learned some good stuff there. Just in the big perspective of how AI is working in enterprise. Really like that little piece on the IoT example. Those of you that, if you have questions, probably the simplest thing to do is just drop them into the chat. I've got a couple here that were sent to me directly. So I will start off with one of those for you, Jocelyn. And again, just feel free to throw things into the chat. Also, I believe we have a couple of the DoorDash coupons still available. So if you haven't filled it out, go ahead and grab yours. But Jocelyn, let's see, what do we have here? Given the technical expertise needed for big data and AI-driven analytics and the presumed costs when, you know, even when accessing a vendor for an AI service, does a company need to be a certain size? Does it need to be large to take advantage of the benefits of AI?
I probably don't think so, because I'm in the business of you know, putting capital into teams that are really small, like 3 to 5 people, and are building AI-powered solutions. Those are really special teams, naturally. But I think that if you're trying to build an AI solution at home, I think you probably need a critical mass, depending on the problem, you probably need critical mass of data. And so if you just don't, like, there are some problems where there's too little data for solving it to be an ML problem. Like, if you're trying to think about, you know, well, let me think of all my customers and figure out which ones would be good to cross-sell different products to. And so all my customers across all my products, which ones might I be able to sort of, if you bought product A, I can also sell you product B and product C. I would say that if you only have hundreds or thousands of customers, you may not have enough data for AI to answer that question. That may just be that you need to do some statistical analysis, but keep selling. Whereas, you know, certainly if you're a very large company who, you know, does, you know, many hundreds of thousands of transactions, your chances are really good that you can get some pretty deep insight into that. So I think it's not so much about the size of the team or the company. I think it's about like the problem you're tackling and how much data you have.
Okay, cool. Here's one in the chat from Peter. You mentioned insight as the first step in using data. What are other levels that companies can get to?
Thanks, Peter. Hi. I think, you know, insight is a starting point. I feel like sort of a cliche saying this, but I think that there is sort of like, we can go from describing things to predicting them. And then we can go, once we can predict things, then maybe we can predict many possibilities and sort of have a point of view about which one is best. And so then we can go from prediction to prescription or to recommendation. So it starts with description. I mean, you know, think about like classic, you know, is it a hot dog or a real dog? Like that's just classification. That's just description. That's insight. It's probably insightful to know if that's edible or not. But you know, that's a starting point, and that can be useful. But I think that it starts to get super interesting, and not just like cheaper and faster than other ways, but like the only way to solve a problem once we're in the territory of predicting and prescribing. So, but you know, again, I think you got to be kind of grounded in an example or an industry.
Cool. Here's another one. For a company that's actively going through a digital transformation process, what you would say is like moving to the cloud. Mm-hmm. Should you incorporate AI functionality after you've gone through that process, or is it better to kind of do the whole thing at once and include it early on in the process of moving your non-cloud enterprise to a cloud system?
I think a little bit, it depends. So if you're talking about the sort of internal capacity building and sort of, you know, accumulating your data assets in your team and your tools, the thing is, I just don't think, as I sort of said in the talk, I just don't think you should big bang it. I don't think you should sort of expect to build the perfect edifice of data lake and then, you know, 1,000 flowers bloom of AI projects internally. I think you've got to sort of start with one project and get it working end to end and show some value and get some points on the board, and then you can kind of gather steam and momentum as you go. So I don't think it's necessary to have done the entire digital transformation of your company. And if you're a big company, that could take a decade anyway. So I think it's more like you want to get some points on the board as you go. And so I do think, yes, it's easier to build AI projects on top of the cloud. I'm pretty upfront about that. And so it may be that if you're in process, you know, and you have moved like one set of data to the cloud and one set of systems, but other things are lagging behind, then like now's a good time to hire your first couple data scientists and build a project that's inspired by and within the scope of what has moved. And by the way, chances are whatever you prioritize to move first to the cloud is probably also a high business priority. And so doing something good about it is a way to make a difference to the company, which is always good. On the flip, so that's the build side. On the buy side, you know, again, there may be some vendors who require you to be on the cloud to work with you very well. But I would say, again, this is another sort of baby steps way to not have to postpone the value of AI for a whole decade. You can actually just, you know, get going and start seeing some results and start gaining some confidence so that as you move more and more stuff to the cloud, you've already got these kind of wins and successes working with vendors to say, hey, look, yes, it is worth it. We can justify building this team, investing these resources in these systems. And then last but not least, if I sort of, you know, double click on AI for the purpose of managing your cloud infrastructure, this kind of AI ops category, or the autonomous data center that I'm so gung-ho about after my long stint at VMware, I absolutely think that as you migrate to the cloud is a great time to think in real time about how AI can help you manage your new cloud infrastructure. Because one thing everybody says about migrating to the cloud is it drastically gives you more velocity and agility, but it actually is often more expensive, not less, than your on-prem data center. And it ends up having way more complexity. Like what you give up in order to get the agility is you bite off a lot more complexity and a lot more management headache. And so if you like, don't wait for that to be the new burning fire, right? Like if your old burning fire is the on-prem data center and you're putting the fire out by going to the cloud, your next fire is going to be, oh my God, the complexity, it's microservices hell, we don't even know how many VMs we have. And so as you move to the cloud is a good time to think about how can AI powered, as I'm sort of, all my old systems management tools go out the window, right? Like the stack's just rewritten. Like I can't I can't manage my infrastructure the way I used to. And so as you're rewriting your playbook on managing your infrastructure because it's cloud now, I think it's a really good time to contemplate AI-powered systems for that.
Cool, that's awesome answer. The question here from Keegan that's a little bit more specific. What are the best ways to deploy deep learning models in 2020? Would you recommend using Kubernetes with Kubeflow or a managed service such as SageMaker?
Oh my gosh, I feel like I should pull in Peter and make him answer this question, because I have to caution you that I have not done this myself. So I'm going to give you like a very general high level answer, which is that if you are just getting going, you probably want to live on a high abstraction. All right, so here's the thing about Kubernetes. Like, big machine learning projects inevitably end up there, and it is the right solution for scale. It is, again, you pay for that scalability with a high degree of complexity and like a management burden. And so if you're just sort of tinkering around and getting going with something and trying to figure out how this is going to work for you, or if your deep learning projects, like if its output is a report, not a product that's going to run at scale, then a managed service may be exactly the right thing to do. I think the analogy that probably speaks to everybody here is that if you're experimenting with building like a SaaS application, you're probably fine on Heroku for a while before you go to native cloud and manage it yourself. And I would liken machine learning projects to that too. But maybe I'll pass the mic to Peter and see if he would say something different, because he's certainly more informed by having done this.
Very little I can add, Jocelyn. Thank you. But yes, again, if you are looking to actually do the data science and benefit from it, then starting with a managed service is easier because you don't have to worry about setting up the infrastructure. If you are scaling a data science project or data machine learning project, and as well as offering it as a service, then yes, moving it to self-hosted to Kubernetes, getting your workflow upgrade capabilities and so on, then you want to move to something like Kubeflow.
There's kind of a talent angle on this too, which is you can get up and running with a data science project with just data scientists, but once you need to manage a Kubernetes cluster, you actually need DevOps people and like distributed systems engineers, right? Like, it's a whole new profile. And so when you're ready to invest in a team of people rather than like a single person building the application is probably when you think about Kubernetes. But like, I pity the poor data scientist who's just like, hey, I want to like make something cool, and like who has to like go figure out, it's just shaving the entire yak.
Awesome, shaving the yak. Here's one from Deepak. Besides IT and IoT, which other domains or verticals do you see where there is a strong need for AI-based solutions and capabilities?
So AI actually got its boots on, well, AI really got its boots on in consumer, okay? So if you think about like the earliest commercial uses of AI, it's like Netflix movie recommendations and search results. Google actually did not use machine learning for search results for a very, very long time. I think Bing was the first like broadly used, but like that kind of thing. And then in 2010, I cut my teeth on machine learning. My first big project at Facebook was adopting ML for the newsfeed. So I would say that those are all like colossally impactful projects of machine learning. We can debate whether they're successes. We might have destroyed the world there with unintended consequences, but certainly search and feed ranking and movie recommendations, like these consumer applications, are really good applications of ML. Then as the technology started to mature enough for businesses to be ready to put kind of mission critical systems on it, it was still the case, like AI doesn't lend itself to a right answer or a wrong answer, right? Like, if you could make a prescriptive rule that says there's one correct answer and one incorrect answer, like, you'd be better off with a program. It wouldn't lend itself to being an ML problem, right? So ML problems typically are things that are probabilistic, nuanced, and like, have an accuracy that is less than 100%. And so the first place where it's safe to use AI is actually in places where it's sort of a convex payoff, right? Where if you get it closer to correct than what you would have done without the AI, you're gonna get a big payoff. But if you're a little bit wrong, you're no worse off than you were without it. And so recommendation systems obviously fall into that category, right? If I show you a bunch of recommendations for products to buy, then and you don't buy them, well, it's no worse than not showing you a recommendation. But if you do buy them, awesome. And so I don't have to be perfectly accurate to be really valuable. And so things like ads and marketing campaigns and sort of sales optimization were among the early wins for machine learning on the enterprise side. And then, then you start to get into more mission critical stuff like deciding whose loans to approve, or figuring out how to do claims processing of insurance claims, or detecting fraud in payment system. And fraud is another one, by the way, that has a really good sort of, that kind of payoff, where the more fraud you find, the better off you are. So so I think as the technology gets better and better and more accurate, sort of more and more verticals lend themselves. I think one that people get super gung-ho about is healthcare, and for very good reason. Like, AI probably can discover drugs faster than human beings can. It probably can enable personalized medicine, where we take in vast amounts of information about you as a human being and identify, instead of like one size fits all therapies, the one that is best suited to exactly you and your genome and your system. What I have found is that AI is moving slowly in healthcare for reasons that are mostly not technology reasons. And I think in Silicon Valley, we get very excited about going and fixing healthcare because we assume it's a technology problem. And I think they have a lot of problems that are not technology problems. So I think unless someone, unless a healthcare tech company can come up with not just a very good application of AI, but a very good entry point that solves the business and cultural problem of healthcare, it will be hard to make much headway. But I would say, outside of healthcare, which I think heavily regulated industries actually appropriately should be slow about adopting AI, because I think we need to be really careful about using AI for things like approving loans that ought to be heavily regulated, that ought to be heavily scrutinized. And we're like, AI can't explain itself super well. It cannot explain why it arrived at a decision. And so, maybe that's fine if it's just deciding what ad to show you, but it's probably not fine if it's figuring out if you can get a mortgage or buy a house. So I think that those ones should be appropriately slower to adopt AI, and that we need to make the technology a little bit more mature before it's ready.
Okay, awesome. From Leo, we have a question. What qualifiers do you use to distinguish AI projects that are hype versus from something that's actually providing a feasible or even a valuable solution?
I'm not sure I understand the question. Is it written down somewhere in chat where I can reread it?
Yeah, it's in the chat. Should be right at the bottom. Leo.
Hype from feasible. Sure. Sorry, I just misheard you. Well, a few things. How when you're interviewing technical people, and it's sort of like, you ask people like the FizzBuzz interview, like programming question, like a super easy question, like, write me the 3-line function that outputs the Fibonacci sequence, and then like an astonishingly large number of people can't even do that. So like there's some simple sniff tests like that in startups too, which is like, oh, we're gonna do AI for XYZ. Okay, well, is anybody on your team actually a data scientist or a machine learning engineer? No, we're gonna hire that after you fund us. Okay, well, then I'm taking maybe that then I have a harder problem, which is to figure out if this possibly could be solved with AI and people, but I know that you haven't solved it. Have you ever built a model? What experiments have you run? What is the accuracy? What data have you fed it? What is the accuracy of your model? How has it improved over time as you fed it data? I think the capability of the team itself is a strong leading indicator of what they're going to be able to build. So those are all things that we can assess even when it's super early. If I think about myself wearing the hat of a company assessing a vendor rather than an investor assessing a startup, I think the existence proof of what it does and how it improves over time. I think how it improves over time is actually a really good indicator, because good AI systems should improve as they learn, as they train on more data, as they get more and better results. And so that's kind of a tell that this is an AI problem. Like if it's perfect on day one and no additional data can help it, then probably it didn't need to be AI, and it's calling itself AI, but that's just like sugar. And likewise, if they don't have something, if they have something that doesn't work very well and they say it'll get better over time, but it doesn't, then you may have a problem that AI doesn't solve. I think, well, I was going to go off on a tangent about chatbots, but that's probably too long a sidebar.
Okay, so we're getting close to the top of the hour, so maybe this will be the last question before we go into breakout rooms. This is from Peter. how important is the understanding of the reasons behind an AI's decisions in the enterprise environment?
I think it depends on the enterprise. So I think it really depends on, so explainability, hot topic in AI, by the way, like startups working on explainability, you know, really could get funded in 2019. So I think that in financial services, in hiring, in like criminal justice, amazingly, I don't know why this is true, but amazingly, like some court systems adopted AI to do like sentencing, I guess because they thought the algorithm would be fair. Or fairer than judges or jury, I don't know. So these are like terrible places to use AI when AI cannot explain itself. I think it's perfectly fine for AI not to be able to explain, you know, how it arrived at a certain marketing campaign mix, as long as like you can test it and see that the results are good and then turn it loose. So I think that this is actually like a policy question, not a technology question. And I think it comes down to, as a society, what decisions, you know, humans may make much worse decisions. Like even take driving right now, you know, I think the bar for autonomous vehicles is going to be really high. Like if an autonomous vehicle gets into a car accident and kills a human, it's probably going to set back adoption and acceptance of autonomous vehicles for years. And yet at the same time, human drivers kill humans all the damn time. And so would we not trade a world in which humans, you know, we could trade for an autonomous vehicle world where many fewer humans are dying, but some are because it's not perfect. And that probably like on some global level is a better world because fewer people are dying. But at least when a human makes the mistake, they can be held accountable for it. They can be not just, you know, financially, but morally. And so, whereas the AI, you know, at the moment, I think we have a lot of difficulty accepting that. So I think that like there is, when these decisions have grave consequences, whether it's a job, a loan, a prison sentence, or a life, you know, I think we as a society have to have like a policy approach to figuring out when we're willing to entrust that decision to an AI versus a human being who we can sort of look at and interrogate and say, why did you do that? I think it's super clear, like I hope probably everybody in this audience is technical enough to know that like, you know, there's nothing magical about it being an algorithm and that algorithms are not mystically free of bias. We train algorithms on data. And so if we human beings have been making biased decisions all along, and this is exactly the data they found, by the way, in the sentencing reform one, you can Google this, is that, you know, if you train the algorithm on a bunch of biased, you know, prison sentences, then it will output, it will predict, it will suggest, it will recommend prison sentences that are based on race, for example, as a feature because it has detected that pattern in past sentences. And so, you know, if we do this blindly, willy-nilly, we risk sort of encoding the worst of human biases and actually, you know, enforcing them and making them last forever and sort of just saying, oh, well, the algorithm was fair. Whereas I think, to me, the upside of AI is that it's going to be a long path to somehow arrive at a world where every human being, where every human judge is bias-free when they're making a sentencing decision. But I think like if we have really good policy and we have really good practitioners and we go clean the data correctly, like it's a lot easier to beat the bias out of a data set than it is to drain it from, you know, a society of human beings. So I think there's a chance that AI can help with this, but I think we've got to be careful. And I think that humans ultimately have to govern this and have to make good policy decisions. And that's my political statement for the day.